How long will I wait in line? Is probably a question you've asked yourself before. Want to know how to answer it? Let's look at queuing theory. Queuing theory is the mathematical study of waiting lines, or queues. A queuing model is constructed so that the queue lengths and waiting time can be predicted. But what does that mean? Let's consider queuing theory's most famous formula, Little's Law. Now it all comes down to A, W, and L, A being the arrival rate. It's basically a number of items that arrive to the system per time period. W representing the wait time. It's the average time an item spends in the queue and system. And L is the level of WIP. It's the average quantity of items in the system at any moment in time. Let's say every hour, on average, 30 new people arrive at a line. It takes an average of 15 minutes to stand in a line and buy a ticket. So at any given moment, there would be an average of 7.5 people in the system. The formula still works for different distributions of inter-arrival times and wait time, which I think is pretty cool. But what if the system is more complex than that? Queuing theorists have been studying these models since the early 1900s. And for some of these, we have mathematical solutions. But for the more complicated ones, like a complex system with priorities and shared servers, where customers can decide not to join if the queue is too long, we may need to use a desk to solve it. This is a computer software that can simulate the customers and servers of the system. We can use it to answer questions like, how many tellers should the bank have working on Fridays at noon? Now, here are some things that can be considered in a queuing theory model. Reneging, which is when customers leave the queue if they have waited too long for service. Or balking, which is when the customers decide not to join if the queue is too long. I'm looking at you 2-hour-long amusement park line. There's also priority queues, where customers with high priority are served first, like the express queues in amusement parks. And lastly, jockeying, when customers can change from one queue to another if they think that they will get served faster by doing so. If you think these formulas are too simple to represent what happens in real life, just remember this quote by George Box. All models are wrong, but some are useful.